Okay, so start off with complete your ACT 6 because you want to stay on pace with the other Algebra 2 classes. Um, Practice 7 should be complete. If you haven't completed that, finish it up. I'm going to review what that was over in this video. And then we're going to go into Lesson 9. We've skipped over lesson 8, but we'll come back to that after we do 9 and 10. So today what we're going to be doing is solving single inequalities. So have your notebooks out, and you can go ahead and get starting. Give your notes a date right at the top there, and try to keep up. You can pause it as you need to pause it. So our target skill today is we're going to solve inequalities. So you're going to have to solve inequalities. You're going to have to graph solutions, and then lastly, you have to write intervals. Now your lesson 7 was on these three things except for the solve part. So we already have experience graphing the solutions and writing the intervals. I'm going to review that right down here below, but just keep in mind this is something you have seen and done. If you haven't done that assignment 7, get in there and get that finished. All right, so let's review. We've got ourselves an inequality. X is being described here. It's telling us the x's are greater than or equal to 2. And so this would be our inequality notation that we'd end up with, telling us, hey, these are our solutions. Then we can graph this. So we'd show it by marking the 2. Remember, your point of interest is where x is equal to that number, or at least that point where it's kind of getting bigger than or less than. So we'll put a point at 2. We also want to put a point that's higher than 2. So we'll put a 3 right there. We'll put a 1 right there. It's going to be an open circle at 2 first. Then you look and you decide, hey, since it says equal to, I can color that in. So I want to know that it equals 2 right there. And then since my x is on the left, I want to go x's that are greater than the 2, and those are to the right here. The same direction that inequality points is the direction of my arrow. And remember, we'd like to draw it right on our number line. However, sometimes, here we go, having a hard time getting my pen working there. We'd like to draw it right on our number line just like this, but since you're using pencil and you can't draw it on your number line to say it's those guys, you can just draw your arrow above it, saying, hey, x's are over here on this side of the 2. They're the 3's and the 4's and the 5's and the 2.3's and the 2.1's, anything bigger than or equal to this 2. And that's all we're doing. Now, the last little bit we had to do is write the interval for this thing. Now, the interval is just another way of writing this inequality or another way of writing this graph, but it's in this method called intervals. And intervals, if you don't recall, we'll review really quick. They always have this kind of format where you put the smallest value that x can be on the left, a comma, and then the largest value that x can be on the right. Okay? And then the only other thing we had is these ends where we have parentheses. When it was filled in, like in our case, we didn't use parentheses, we used hard brackets. All right, so we'll see some examples of this right now as we go through these. So this one I'm trying to indicate that my low number that x can be is 2. So I'd write down the 2, and then I'd say, well, what's the biggest number it can go to? And this is where it goes forever to the right, which we call our infinity. And then we say, well, on the left end, do I want to include the 2? Yes, I do, because it's filled in. And rather, infinities always get just a parenthesis on them. You don't know the end of infinity, so you can't include it. And I should have done that in purple, because that's what our interval notation looks like. So it corresponds. When I say interval, I'm talking about that. When I say graph it, we're talking about this. And when we say write it as an inequality, we're talking like that. All right, so I'll jump over here. If you want to try these on your own, you can pause the video and then try those. We got one right here, one down here, and then another right there. All right. So in this next one, I've got x is less than -4, so I'll put a mark at -4. I'll mark a bigger number, -3, a smaller number, -5. Remember, the bigger the negative number, the smaller it is, the further it is away from 0 on the left-hand side. I will put an open circle at -4. It's not colored in because it doesn't equal. And I'll draw it to the left because I want to go to where x's are smaller than the -4. So there's my graph, and here's my interval. It starts at this -4 basically, but it goes down and gets smaller. So actually my small number it goes to is on the left here. Remember, I have to put the small number first. So when you go forever left, that's your negative infinity side. So I'm going all the way from the small side of negative infinity, and then the big number I stop at is this -4, even though -4 isn't very big. The -4 is not filled in, so I use a parenthesis, and infinities always get parentheses. So that would be my interval. Guess I should have written that thing up here a line higher, but you get the idea. It's in purple there. All right, the last two. Now these are the compound or the double inequalities. Remember, they have a connector in it, an or statement, and then other times they have this and statement. Okay. If it's an or, you just have to be in this group, or you can be in this group. If it's an and, you have to be in both of these groups to be in your final solution. When we graph these ors, remember we have to put 2 points on our number line, and we always want to put the small number on the left. So we'll put a -3 here. We'll put our 2 here, and that's enough because we've established direction. I know the small numbers are left, the big numbers are to the right. I put an open circle right at the -3, and I don't want to be equal to it, so it's not filled in, but I want x's that are smaller, so it goes to the left. The other inequality that it's joined with this or, x's start at 2, so I put an open circle at 2, and this time I want to be greater than the 2, so I go to the right, and it's not filled in again. All right, so let's write this thing now in interval notation. So the left-hand side here, over here, I'm going to negative infinity, so it's very similar to the one we just did, and it goes up to -3 and then it stopped. Oh, soft. Then it's an or statement, so we use the U for union, and it starts at 2 and goes to positive infinity like that. And the last example, greater than -5, less than 0, so I want -5 and 0. I'm going to be bigger, greater than the -5, so that's going to move me to the right. So that's all of these numbers. Let's do it in blue so we can see it here. It's going to be everybody going this way, but I can't go past the 0 here because the and statement says x's have to be smaller than 0. So at 0, my line would have to stop. But I can be less than 0, so that moves me in this direction to the left, and you can see these two inequalities overlap in that region. And those are the numbers that are both bigger than -5 and at the same time less than this 0. Now this interval is the easy one to write because now the low side is very apparent, it's -5. And the high side is 0, and they both get soft parentheses. Just so you can see me use a hard bracket here, I'm going to go back up here and say, hey, let's say the original problem instead was this. So I've added this equality sign here. All that would change in your graph is this circle would then be filled in. And if that circle is filled in, then your parenthesis at the end here, it gets changed to a hard bracket. So that's when we use the hard square bracket when we want to include that endpoint because we can include where it equals. All right, so that's a review of what we've been doing. That took us a little bit too long there, but you can skip through it as you need or see fit. Now up here, we are I'm going to solve inequalities and then graph just like I showed you, and then write intervals just like. Now let's get to the stuff we're doing today. If you So let's just review here. I'm going to solve this equation really quick, and then we'll compare it to this inequality here. And then I'll tell you the only difference you got to be worried about, and you'll be ready to go. All right, so if I'm solving an equation, I can drop my dotted line there. I've got my left side, I've got my right side, and I want to get my x alone. So I'm just going to add my 6, those are like terms, equals 2x. Negative 6 and positive 6, they will cancel each other out. And so I'm at this point here. This is 2 times x. That's how we write 2 times x. And so I'll undo that by using division. So I'm dividing by 2, which I show as a fraction, like that. The 2 divided by 2 is 1, so this is just 1x now, or just x. And that equals, and 26 divided by 2 is 13. And then we flip this around and we say x is 13. Real simple. Turns out that inequalities, and it's an inequality because you notice it doesn't have this equal sign here like it did over here. This is a greater than, that's an inequality. And we solve them almost identical to equations with one exception. Now this problem doesn't have that exception. I'm just going to run through it real quick so you can see I did the same thing. That's the addition property of equality. And now we could say for inequalities as well. Because if I add 6 to both sides, I can still keep my inequality going just exactly like it was. And then I'm going to, just like I did over here, divide by 2. I want to undo this 2 times x, and I will divide by 2. Now, our answer is a little bit different, because now I don't have this equal sign, but I still want to rotate my equation so the x is on the left. Now when you rotate it, we're rotating the entire equation in this case. The x has the inequality pointed towards it. So when I put the x on the left-hand side, the inequality has to still point to x, so it still is the smaller of the two numbers I'm comparing. So make sure you put that x on the left and rotate your inequality correctly when you do that. Now in this case, when I get this answer, this, remember, is a whole mess of answers. So I'm just making a quick graph here. And I've got 12, 13, and 14 on it. And so this would be everybody less than 13. So this really represents a lot of solutions, whereas these equations, we only get exactly one solution to them. So that's one of the things different about inequalities. Here's the second thing, probably the most important thing you have to remember for today. And it's this statement right here in black. So I'm going to read it to you, try to highlight stuff as we go. The rule is, when solving inequalities, so this only applies to solving inequalities. If you multiply or divide by a negative number, then you must flip, flip, flip. Oops, highlight, flip. Use a red highlighter on that thing. Flip the inequality, and I better put, and I should have added this, the inequality sign to keep the inequality true. This is a must. If you need to pause the video to get that written down, write it down. And now I'll explain why this has to be done this way. I have an equation here on the left and an inequality on the right. Before I solve either one, I want to show you a true fact here. Okay, when I'm working with equations, let's say I've got an equation that says 4 equals 4. If I divide this left side by negative 1 and divide this right side by negative 1, our division property of equality says the two sides should still be equal, and they are. When I divide 4 by negative 1, I get negative 4, and when I divide 4 by negative 1, I also get negative 4. So hey, this division property of equality, it holds. Dividing both sides keeps it true. Now, watch what happens when I start with a true inequality. So let's say I've got 4 is greater than 3. Again, true. And what we're going to do is just see what happens if, like I did before, I divide both sides by the same number. And again, I'm going to choose a -1. Turns out this is true for any negative number. I'm just using a -1 to make it simple for us. So again, I get the same result here. I get 4 divided by -1 is -4. But on the right-hand side, I now get -3. And so look what's happened. 4 is bigger than 3, but when I divide by a negative, -4 is smaller than -3. Think about how we define small. It's by how far you are away from the 0 on the left-hand side of a number line. So this -3 is smaller, or rather this -4 is smaller than this -3 is right here. Okay, it's further away from 0 on the negative side. And so I can't have my inequality point the same way. I'm going to have to flip that darn thing around to keep it a true statement. And this happens every time. And even though you won't see it happening, we know as mathematicians this will always occur. If this side's bigger, when you divide by a negative, it now becomes smaller. And so we just always flip the inequality to keep it true. Now the same thing happens if you have something like 4 is greater than 3 again, and you multiply by a negative number. Take both sides times -1, I get -4. I've multiplied by a negative, so I have to flip the inequality, and now it stays true. Okay, so let's compare it. I'll show you one in the equation here. Okay, there's just a nice equation. I don't have to worry about this. I add 6 to both sides, and here I'm going to divide by a -4 to solve it. And my equation is going to just stay true. I don't have to worry about anything. I'm going to do the same thing now over here with the inequality, but because it's an inequality, this new rule applies. I'll add 6. 16 is less than -4x. Pay attention to when I do this switch here. In this step now, I'm going to show I'm divided by -4. That's my division property, but this is now a division property of inequalities. So -4 divided by -4 is still 1. That gives me an x. I now have to flip my inequality around because I just did that division. And 16 divided by -4 is -4. I just do my math. And now finally I'm going to do that whole flip. Remember, I want my x on the left, so it points towards the x now. So my final answer is x's are less than -4. This equation, or this solution rather, could then be graphed. So I want the x's that are less than -4. Ran out of paper here. There they are, to the left of the -4. And then if I want the interval, negative infinity up to -4, and they both have parentheses. All right, just one example. So seems like a long lesson, not really a long one though, because all you have to do is remember the new rule. You just solve things like they are equations. But if you ever multiply or divide by the negative, flip the inequality. So here's one we've seen before. We've done it with the equal sign. First thing I would do is undo my subtraction. I'd get -x over 3 is greater than or equal to 1. Now this is still causing a lot of students a problem. This fraction here, you want to get rid of the 3 and the negative at the same time. What's been helping students, I think, is, hey, when there's a single x or a single term up there, you can put that negative in the denominator if you want to. Now, you don't even have to show that. Math people should know that, hey, that negative sign could be at the top, in the middle, or in the bottom, as long as the fraction is a negative fraction. But when you see it in the denominator like this, it makes sense then. Since x is divided by -3, you're going to want to multiply by a -3. so that this numerator negative 3 cancels that denominator this denominator negative 3. But if you do it to that side, you've got to do it to the other side as well to keep it nice and balanced. But that's multiplying by a negative while you're solving an inequality. So while I get x here and I get negative 3 on the right side, I have got to flip the inequality around to make sure I get the correct solutions. All right, let's graph this guy real quick because we want to show this when we solve these today. And we'll color it in and go to the left. And here's the interval that we just talked about on the first page. I'm including the negative 3 because it's filled in and it goes all the way to the negative infinity on the low end. I do want to address one other thing because I have seen students doing this for this problem that I just solved here. You don't need to see this, but I do want to show it. So if you are solving a problem like this one I just completed in a different fashion, as long as you're doing it correctly, it's fine with me. So here's what some students are doing. They're saying, hey, I want to get rid of this fraction, and they're multiplying by a 3 immediately. And that's fine. I would encourage you to multiply by a negative 3, though, first, if you're going to do it this way. Now, if you try to do it this way, and I'm going to use the negative 3 because I think it's more efficient to do it this way. Now, I've already shown you once this negative right here, you can treat like it's in the bottom. I'm just not showing that, but we're treating it like it's down there. But the difference is when you multiply an equation or an inequality by a number, you have to multiply the entire side by that number. And so really you should be taking this entire side like this times that negative 3. Now what this causes you to have to do is essentially distribute that negative 3. Or maybe I should say essentially what you have to do is take negative 3 times this and this. That means you've taken it times the entire side. Okay? And lots of times you don't show this math, at least this first step of math, because it's rigged. The negative 3 is going to cancel the 3 and the negative both at the same time, making it just a positive x. And that's kind of a beautiful step right there. The other product, this negative 3 times this 4, you're going to have to work that one out. In this case, negative 12. Remember, I did that to the left side, so I got to take the right side times it as well. That gives me a negative 15. And because I multiplied by a negative, I've got to flip it. But now you're only one step away. Add 12, add 12. You get x is less than or equal to negative 3. Exactly the same answer we got on the left-hand side there. All right, so you can do that if you would like. All right, now that gets you to your homework, everybody. So let me work here, and you can take a look at these things. Here's what I'd like to see. I've got number 1 here. It's all set up to solve. I just got to add 2 to both sides. No need to flip the inequality when you add or subtract. There we go. I just want to rotate that equation. It has to point towards the k. So there I've got my inequality. Then I want us to draw a graph of it. So here's my graph of it. Negative 8, negative 9, negative 7, filled in, pointing to the left where I'm less than. And here is my interval right below it. And you don't have to write these words, but you should write down the interval and what it is. And there I go. I'm not including negative infinity, but I am including the 8. And I'm done. So we want to graph the solution on the paper and put the interval. I don't think there's any surprises on this thing. Let's scan through it real quick. Now everything looks pretty straightforward, like there's one step, then some two-step equations. Make sure there's a couple on the other side. Looks like you're going to have to do a little distributing here to solve it. And when distributing there, don't forget there's a -1 right there that you are distributing. That should get you going.